All right, and so we're back now. As you can see, if you have already tried out the two problems, C and D on this side, take a moment to check your answer there carefully. Maybe pause the video so that you can look at the answers and maybe fix whatever you need to fix. But the next thing we need to talk about here is dividing rational expressions. When we're dividing rational expressions, aka dividing fractions, we do need to remember one thing: we don't divide fractions. So back in your elementary days, they said, when dividing fractions, apply the KCF, not KFC, KCF method. Now, if you forgot what the KCF method, maybe that was just my teacher that taught it that way. The rule is we do not divide fractions. Instead, we keep the first fraction. So we keep the first fraction. We change, that's what the C is for, we change to multiplication. I'm just going to say to multiply. And the F stands for we flip the second fraction. So that's the process there. And then the great thing is that as soon as we do this, as soon as we keep the first fraction, change to a multiplication, and we flip the second one, we'll actually just go back and do the same steps we did earlier, where we're going to, of course, create a single fraction, multiply straight across, and then second, we'll factor and cancel just the way we did before. So notice how in this little property here, they applied the KCF. See, they kept the first fraction exactly the way it is. There's the C, there's the change to multiplication, but in order for that to work, they had to flip the second fraction over. So as you can see right here, the second fraction used to be C over D, and it became D over C. So we're going to do a little bit of practice here. We're going to do 3 of the problems. Because we want the space for these problems here, notice how we have deleted letter D to get that extra space. All right, so here we go. Now, very first thing we're supposed to do is we don't like the division, so that's why we do the KCF. We're going to keep this one exactly the same way. So 7x, 2x minus 10. We're going to change it to multiplication. There's the change. And now we are going to flip this one over. And when we flip it over, our x squared minus 11x is now at the top, plus the 30. And the x squared minus 6x is now at the bottom. All right, but now we're ready to do what we just finished doing earlier. You see, it's now a multiplication. So I'm going to create a single fraction. But you know what? We're going to take care of the factoring as well. So I'm going to give it a little bit of space here because I want to take care of the factoring at the same time. So the first question is this: can 7x be factored? Absolutely not. So I'm just going to write 7x. And if you want to put in parentheses, go for it. But we can't do anything with it. So then I look at this one right here in blue. When I'm looking at this one carefully, we say, all right, well, can I factor? Of course we can. It doesn't have a GCF, but if I look at it carefully, I can definitely do an X factor for it. The top would be the 30. The bottom is a negative 11. Well, if that's a positive and this is a negative, then they're both negative, and we end up with a 5 and a 6. And of course, because there's no a value in the front, then I can go right in and write in x minus 5 and x minus 6. There, that one has been officially factored. But we have to keep going. We still have a few more that we have to look at and see if we can do anything else with them. So when I look at the next one does have, of course, this 2x minus 10. Now, 2x minus 10, for this one, there is something that we can do. Notice it actually has a GCF. And the GCF of a 2x and a 10 is actually a 2. Now, remember what GCF means. The GCF means that 2 is going to go outside of a parentheses. And then the question is, I'm going to divide these by 2. So 2x divided by 2 is 1x. 10 divided by 2 is negative 5. All right, so there we have that one. And then, of course, we have one more to go. And for this last one here, Well, we're going to look at the x squared minus the 6x. So let's see this one here. Again, I do see that it has a GCF. They both say x, so I'm going to take out a single x from both. But look at how it affects the value. I'm going to put a dot just to connect these. There's the x for my GCF. But now I'm going to take an x from here. Well, then I still have an x left over. If I take away the x from here, well, then I have a minus 6. And just like that, we're ready to start doing a little bit of more math with it. You see, everything has been factored, and I've created a single fraction already out of it. So if I look at it carefully, we could say, all right, well, look, the x minus 6 is going to go away. The x minus 5 also going away. But if you notice, there's this single x right here. And yes, that single x is there too. You might say, yeah, but it's with a 7. These are just coefficients, nothing else. So we could actually cancel out the x because they're exactly the same. X to the 1, x to the 1. They can get canceled. So after all of that, look at what we're left with. On the top, the only thing left was a 7. At the bottom, the only thing left was a 2. And so sometimes that's going to happen where almost everything goes away, and that's what we're left with. But just keep in mind, when you're working with the Big Ideas math assignment that we're working on today, there's a couple problems where they're going to say, all right, but there's a few x's that we threw out. So look, we actually threw out 3 things in this problem. And if you've caught on to the system or the method, we almost have to think of it as opposites. Except for the x, this has no number attached to it. When you cancel out a single letter, well, then it's 0. We also canceled out an x minus 5. Well, if I think of the opposite of that, then 5 is also thrown out. And then if this one says x minus 6, well, then x minus 6 means the positive 6 shouldn't be used. So remember, on Big Ideas, when a letter disappears from the bottom, it's really the bottom that's the issue. It's called the domain concept. When something gets tossed out from below or gets canceled out, we kind of make a list. We keep a list of the values we're not allowed to use. Now, I'm going to do the one right at the bottom here. Since we're already there, we'll do this one here. Again, we don't like to divide. We instead like to do some multiplication. In order to do that, I keep this fraction exactly the way it is. And then this fraction, all I have to do is flip it over. Okay, so there it is. And now it's time to ask ourselves, okay, well, is there something that can be factored out? So I'm going to create a single fraction. This one's a little smaller, so I'm just going to put it here. There's my single fraction. First question, can anything be done with the 7? No. All right, I'm just going to write it down. Then the next one, it's right next to it. I'm going to put a dot for now. When I look at this one right here, the 3x plus the 3, well, there is something that I can do there. I mean, they both say a 3. Well, then this has a GCF. Don't forget, GCF is always available. It's part of factoring. And a 3 does come out of this one. So I'll write the 3. And in parentheses, let's see, I divide this by 3. I still have an x. I divide this by 3. I still have a 1. All right, so that's what I have on top so far. Now let's look at the bottom. Now, if you look at this one, it doesn't have a GCF. It doesn't even have a power of 2. That means that's already the factor. I don't do anything with it. Same goes for this one if you think about it. Look, there's no GCF. There's no power of 2. You just have to make sure you're writing it in parentheses because now they just go right next to each other. Remember, we're multiplying straight across. And so now when I see this entire thing and we go, all right, well, what can cancel out? Well, there's really only one thing that will go away. The x plus 1 is officially gone. Leaving me with, now be careful here, look at the top. You might say, oh, a 7 and a 3. Yeah, but it says times. Remember, everything was multiplying. So this is actually 7 times 3. So then I have a 21 on top. And the only thing left at the bottom that wasn't crossed out is the x plus 2. Now you can put it in parentheses or not. There's nothing else there. But there's my answer that I would write down in Big Ideas. But remember, in Big Ideas, they are going to ask, what's that one x value that should be excluded from all of this? Well, because we canceled the x plus 1, then -1 is the excluded value for x in this problem. So sometimes some of the problems will be a lot easier. In fact, it was already factored for me for some of these, right? They're technically already been factored. I don't have to do factoring when it's already in parentheses. Which brings us to the last problem here for this one. When I'm looking at letter B, well, again, it's division, so we don't like to divide. So here comes the changes. 11x, 3x minus 9, times, now we're going to flip this one over x squared minus 5x. Here's where we're going to create our single fraction. And here we go. It just says 11x. We can't do anything with it. All right, 11x. There, that one's done. Now I'm going to look at the one next to it. Well, let's see. If I look at this one here, this one does have 3 terms. It doesn't have a GCF. All right, so here we go. Here comes our X factor, or diamond method. There's the 15. There's the -8, which means 15 and -8. So that is a negative and a negative. All right, that's the only way to get a positive 15. And then to get the -8, well, it's just a 3 and a 5. It has no a value that's visible. It's just a 1. Then I'm going to go right into x minus 3 and x minus 5. So the top has now been officially factored. Well, now let's look at the bottom. When I look at this one, well, it's a 3 and a 9. First question. I know there's no power of 2, but you always question GCF. And this one right here does have a GCF. A 3 goes into both the 3 and the 9. So we write our GCF. And in parentheses, I'm going to divide everything by 3. So 3x divided by 3 is 1x. 9 divided by 3 is 3. All right, there, that one's done. And when I look at this one, you might say, yes, it has a power of 2, but GCF is always first. And the GCF of x squared and 5x is the actual x itself. So I'm going to take out an x from both of these. So that's what I'm going to put down here. So I'll put a little dot for now, just kind of as a placeholder. They're multiplying. There's the x. So if I take out 1x from here, well, then I still have 1 left over. If I take out the x next to the 5, well, then I still have a -5 left over. So now let's see if there's some stuff that we can cancel now. So let's see. X minus 3 definitely gone. X minus 3 is gone. X minus 5 should also go away. And if for some reason you think, okay, then that's it. That's all that can go. Let me just show you what happens. So here's my fraction, which looks like it's about to be my last answer. The only thing on top is 11x. The only thing at the bottom is a 3 and an x. So if you notice, if this is the case, if this happens to you, you should know you're not done. When you have a fraction, if you're simplifying, you should never have the same letter on top and at the bottom. In fact, in this case, we could have canceled the x's as well, because they both have a power of 1. And so my answer here was really 11 over 3. That's my answer. But there are some exclusions, right? There's some x's that we should be excluding from this situation. And we canceled out technically, look, even this one counts. We canceled out 3 of them. So there are 3 x's that are not allowed in this problem. Let's get rid of this one first. See, when you got rid of this x, that's the 0. And then for this blue one, you said x minus 3. Well, then the only x I can't use is positive 3. Here it says we can't use the x minus 5. Well, then the only x that's excluded, positive 5. And these would be the 3 exclusions that we would have on big ideas. So just remember, when you cancel out a letter that has no plus, no minus, automatic 0 is our result. All right, so with that said, hopefully you have a wonderful Thanksgiving break, everybody. And don't forget, you only have one assignment for today, and that's the big ideas math assignment, the homework that you have there. Have a wonderful day, everybody.